So for this one, I'm going to use the definition of derivative, and I guess I'll just use the one with the h's in it. So we want to show that that the limit as h goes to 0 of f of x plus h minus f of x over h. So I want to compute that limit. And what is my function f? So I have to kind of deduce a little bit from the notation here that it's wanting the derivative of this function. So my f of x is x squared minus x here. And then this should be my answer in the end. So I already know what the answer I'm shooting for. I just need to show it using this definition of derivative. Okay, so let's plug these values into our function. So this is the limit as h goes to 0 of, I'm going to plug in x plus h squared minus x plus h, and then minus my function x squared minus x all over h. So do a bit of algebra. When I square x plus h, I'm going to get x squared plus 2xh plus h squared minus x minus h minus x squared plus x. When I distribute that negative sign, it makes this last x positive. All right, all of that over h. And now I want to look for terms that are going to cancel out here. So I have a positive x and a negative x, so that's going to add to 0. I have an x squared and a minus x squared, so that adds to 0. Let's see what's left here once I finish simplifying. I have 2xh plus h squared minus h all over h. And so yeah, so I can pull an h out of all those terms on the top. And when I do that, I can see that I have a h divided by h, and h divided by h makes 1. So now I have the limit as h goes to 0 of 2x plus h minus 1. And at this point, I don't have that pesky h in the denominator. So I can go ahead and let that limit as h goes to 0, I can just plug in 0 for h at this point. I couldn't do that before because I had that h in the denominator and it wouldn't be defined. But once that h is gone from the denominator, I can go ahead and plug in 0 for h. So I get 2x plus 0 minus 1, which is just 2x minus 1. And hey, that's the answer that I was looking for up there at the top. So we're done. All right, for this next one, I'm running a marathon. I hear the timer call out 12 minutes as you pass mile marker 2. And then part A says, as you pass mile marker 5, you heard the timer call out 33 minutes. What was your average speed from mile 2 to mile 5? So basically what we want to do to compute our average speed is we're going to do the change in distance over a change in time. And we always do that because when I think about speed, it's usually speed is distance over time. So, you think about miles per hour or something like that. So the change in distance here, so we went from mile marker 2 to mile marker 5. So it's going to be 5 minus 2 over, and then at mile marker 5, our time was 33 minutes. And at mile marker 2, my time was 12 minutes. So I end up getting 3 over 21, which I can write that as 1/7, or I can write that as, I guess we could just write it as 1/7. So what is that? What are the units there? That's miles per minute. So you're running 1/7 of a mile each minute. I guess you can convert that to miles per hour if you want, but anyway, there you go. If you passed mile marker 5 at 33 minutes, what average speed do you need to run for the remainder of the race to meet your goal of completing the 26.2 mile marathon in 175 minutes? Okay. All right. So again, my rate of change is the change in distance over change in time. And so the different distances I was given was 26.2 minus 5 over 175 minus 33. And so if I compute that, we have 21.2 over 142. So I get 0.1492 miles per minute. For comparison, let's look at that 1/7 in fraction form, which is approximately 0.1428 miles per minute. And so we're going to have to pick up our pace a little bit to meet our goal.